Right triangle similarity, a key concept that we're going to be diving into. It's a core concept of trigonometry and geometry that I like to say it kind of unlocks the world of it, because knowing this concept is really important, especially for things and laws of trigonometry, like laws of sines and laws of cosines, and you'll understand what that means later on in this little course here. Um, so, what is triangle similarity? So, triangles are similar when their corresponding angles are equal and their corresponding sides are proportionate. And I'm going to be going over 3 examples today. So, A, and AA is when you have 2 angles that are the same. So, I don't know, let's look at this 30, 60, 90 right here. So let's say we have a 60-degree angle and a 30-degree angle. If I drew 2 triangles, well, we already know this is going to be a 90-degree angle for 2 reasons. Because, first of all, we already know this is a right triangle. A 30, 60, 90, that's going to be a right triangle. If we know one's 30 and one's 90, or one's 30 and one's 60, we know this must be 90 because we know all 3 angles must equal 180 degrees total, summed up. So the sum of all 3 angles in a triangle must equal 180 degrees. We know 2 angles, one to be 30 and one to be 60. So 30 plus 60 is 90. 90 minus 180 is 90. So we know this one must be 90. And that goes for if I were to even draw it smaller. So if I were to draw a smaller 30, 60, 90, it's going to be the same situation, you know. This will be 60, this will be 30, and this will have to be 90 because, you know, 60 plus 30, it's 90. 90 minus 180 is 90. So we know that. It's just different sides. This is similar. Similar means that they're the same shape, but they aren't the same size. But in some instances, they can be the same size. And this isn't just in 30, 60, 90s. You can have it in a triangle like this. All right, so we can have, you know, let's say we know this angle and this angle, but we want to find this angle. So let's say this is 30 and this is 30. Well, we know all 3 angles in the triangle must sum up to 180. So we can say 180 minus, well, we have 2 30s, so we can do 30 plus 30, which is equal to 120, because, well, we know this segment right here is 60. Looks like a 6E, if you're asking me. So we know that's 60, and 180 minus 60 is equal to 120. And if I were to draw another version of this exact same triangle with 2 30-degree angles, it could be this, which, if you can't tell, is larger, but it's going to have the same angles, meaning they're similar. So they're the same shape, same 2 angles that we know. In fact, they all have the same angles. They'd just be different sizes. The next piece, or the next little type of triangle we're going to go over is SSS, and this is where things get a bit interesting and fun, for me at least. So SSS here. So we know 3 sides of the triangle. So let's take this triangle, and let's say this is 10 centimeters, and this is 8 centimeters, and this is 4 centimeters. In fact, I'm sure I can make that a bit bigger. 4 centimeters, right? Well, here's the thing. What if I took a triangle like this? It's smaller, right? Well, let's say this is 5 centimeters. That's 4 centimeters. And this is 2 centimeters. Well, we can prove that these are similar because the sides are proportionate. We say, well, this side is similar to this side, 10 and 5. Here, let me do it in the same color, actually. So let's do 10 divided by 5, right? And this is proportionate. Now, let's use a different color. Now we notice that this side and this side are similar. So 8 divided by 4, let's make that ratio. And then lastly, we notice that this side and this side are similar. So 4 over 2. But here's the funny thing. We know these are going to be proportionate because if we do the math, 10 divided by 5 is 2. 8 divided by 4 is 2. 4 divided by 2 is 2. And since these ratios are all equivalent, we know these are all proportionate, so this must be similar. Because they're the same shape, but they're not the same size. Now let's look at SAS, which will be the last one for this quick episode. So SAS, or side angle side, one angle which must be between the two sides we know of, and it must have two proportionate sides. So let's look at a right triangle again. So let's say we have another right triangle. So we have two right triangles here, and we know two sides. We know X, we know Y, and we know here, right? So we're going to say this is 30, and whatnot. And so let's go over SAS real quick. So we have a side, which is X, we have Y, another side, and then we have 30, which is our angle, and we could just say A, for example. So this angle is between these two proportionate sides. And if we were to prove that this triangle is proportionate to this triangle, this side must be proportionate to this side must be proportionate to this side, and obviously the angles are going to be the same. And I'm only saying that just based off this diagram here. It could be different in many situations. So here, let's go over this again. So let's get rid of that. Now let's say, here, I might even get rid of that triangle there just to make things a bit easier. Make things a bit more realistic here. Okay. So let's say this side is 8, 6, and 2. This would be 1, this would be 4, and this would be 3. Except that's a side. I made a mistake here. I did that the last time. So let's say that's 8, and let's say that's 6, let's say that's 3, and let's say that's 4, and let's say that's 30, and let's say that's 30 as well. So we have two of the same angles, right? And then we have two sides. So we know this is an SAS because we have a side angle and a side, but the angle is between the two proportionate sides. And same here, we know that the angle is between our two known proportionate sides. So we know they're both SAS. But how do we determine that they are proportionate? So we know A, in this same situation, is similar to 4. So we're going to do 8 divided by 4 again. We did that here. It's interesting. Coincidence. And we'll use blue again, why not? And we know 6 is similar to 3 over here. So 6 over 3. And how do we know that they're proportionate? Well, we know 8 divided by 4 is 2. 6 divided by 3 is 2. And we know that these ratios are the same, so they're proportionate. The angles are the same. We can confirm that they're both SAS. So these two are similar. Note they're the same shape, but they're different sizes. Same over here, they're the same shape, different sizes. These are the same shape, they're different sizes. These are the same shape and they're different sizes. So these are all similar right triangles. Besides these aren't right triangles. But we know that these right here and these are all similar right triangles. And that is similar triangle. These are similar right triangles, right triangle similarity.